Darwin's paradox. About 2 centuries ago, Charles Darwin sailed aboard a ship called the Beagle through the Indian Ocean. Although the warm blue water seemed like a highly suitable environment for supporting life, Darwin observed that sea creatures were scarce, seeing only the occasional fish in the clear ocean. Yet upon reaching a group of coral islands, as the Keeling Islands, he found an abundance of marine species around them. What was it, he wondered, that caused a coral island to become a fertile oasis amid the nearly lifeless desert of the ocean around it? This mystery, which became known as Darwin's paradox, has long fascinated scientists. Since Darwin's time, they have determined that the very clarity of tropical seas is the reason for their lack of life, as they are not clouded by the tiny organisms known as phytoplankton, which are the main source of nutrition for marine ecosystems. In the Keelings, however, corals and other sea creatures, such as shrimp, have access to phytoplankton. Nitrogen and phosphorus, nutrients required by phytoplankton, are also present in the waters of the Keelings at levels high enough to sustain the reefs and various marine creatures. The factors supporting the growth of phytoplankton are known as the landmass effect, or IME. What puzzled scientists at the time, though, was how nutrients could be maintained within the reef ecosystem, rather than being washed out to the waters around them. Researchers have finally put together all the pieces to show how the IME works. It begins with the formation of a coral reef on a high spot on the ocean floor. Corals need sunlight, so they do well in shallow water, and reef biodiversity is higher when they are located on gradual slopes rather than very steep areas. This is because gradual slopes are important for another key IME factor, upwelling, which is the movement of nutrient-rich cold water from the deep ocean to the nutrient-poor but brighter areas above. This provides food for the phytoplankton that feed corals. Sea creatures known as sponges are another key part of the process, as they suck in the waste products of both coral and phytoplankton, convert the products into substances that marine life higher up in the food chain see and consume, and then expel the substances into nearby areas where they are eaten. This keeps energy and nutrients in the closed loop of the reef ecosystem. Nutrient concentrations in the reef ecosystem are further enhanced by organic matter from creatures that live and die both onshore and on the reef. Tropical coral reefs are an important resource for the fishing industry, but they also protect coastal areas, buffering shorelines from the effects of storms and floods. As climate change raises global temperatures and alters the movement of ocean currents around the planet, reef ecosystems will be affected significantly. It will become increasingly vital to better understand the IME and take appropriate action to preserve it so that the harmful effects of future weather patterns on coral reefs can be reduced.